Hey guys, welcome to Pre-Calc lesson 7.7. We are going to do a couple more mathematical induction proofs. Okay, our first proof, 9 plus 15 plus 21 plus dot 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 plus 6n plus 3 equals 3n squared plus 6n. So what's nice about this one? It's already expanded for us. It's not in summation notation, so I don't need to do any work there. Remember our three steps: show, assume, prove. First thing I'm going to do is show that it works for n equals 1. So n equals 1 is simply the first term. I know it's going to be a 9. Or you can plug a 1 in for the n here. And you have to plug it in both of those locations as well. So let's see, 6 times 1 plus 3 equals 3 times 1 squared plus 6 times 1. That's 6 plus 3, that's 3 plus 6, 9 equals 9. Good. Works for n equals 1. Next, we assume it works for n equals k, which basically means take your expanded notation, replace the n's with k's. All right, so doing that, I get 9 plus 15 plus dot 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 plus 6k plus 3 equals 3k squared plus 6k. Now remember from prior lesson that this has to be included in our next step, because what we do next is the prove step. Prove n equals k plus 1. So I'm taking this and then I'm adding one more term to it. Okay, so it's 9 plus 15 plus dot 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 plus 6k plus 3 plus what I get when I replace that k with k plus 1. So I've got a 6, and I've got a plus 3 I have to include in that. That's going to be my next term. 6 times k plus 1 plus 3 equals. Now over on the other side, I replace both of these with k plus 1. Use your parentheses. 3 times k plus 1 squared plus 6 times k plus 1. Now, the key to the whole proof is in this next step. These two series are equal. Since this stuff here is equal to 3k squared plus 6k, I'm going to take that and replace that part of it down here, and then I can get the two sides equal. So I take this 3k squared plus 6k and I replace all of that stuff with it. 3k squared plus 6k, and then write in the rest of what you have. Plus, and here we can do a little cleanup, right? I can distribute here. That's pretty easy to do in my head. 6k plus 6 plus 3 equals, and then over here we'll do some cleanup as well. Remember, k plus 1 squared is simply k plus 1 times k plus 1, which is k squared plus 2k plus 1. But don't forget we have a 3 in parentheses in front of that. 3 times k squared plus 2k plus 1 plus, let's distribute the 6, 6k plus 6. Now you need to get the left and the right sides equal. Okay, so over on the left side, let's combine all our like terms. That gives me 3k squared plus 12k plus 9. That's all you can do. So you know all of this stuff over here eventually has to equal 3k squared plus 12k plus 9. Don't do too much in your head though. First, let's distribute the 3. 3k squared plus 6k plus 3. And then don't forget you have the plus 6k plus 6. And then you can combine your like terms. 3k squared plus 6k and 6k is 12k. And that's 9. And that's what we have over on that side. And we've just proven that identity. This is pretty close to test level. Maybe a little bit more algebra involved in this step here. But again, the key to all of this, I would say these steps here. Pretty easy, but this is the critical step in an induction proof. Okay, I just have one more. Prove the summation as I goes from 1 to n of 4i plus 10 equals 2n times n plus 6. So the first thing I want to do here is expand. All right, whenever it's given to you in summation notation, let's expand it. The way we do that is we start with a 1, we put a 1 in right there. 4 plus 10, well, that'll give me 14. plus, now I take a 2, put it in here. 4 times 2 is 8, plus 10, that's 18. Take a 3, that's 12, plus 10, that's 22, plus dot, 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 plus, put in an n, 4n plus 10. So I've expanded this summation right here. The last term was what I get when I put an n in there. Now the other side is simply going to be that. 2n times n plus 6. So now our proof. Show it works for n equals 1. Okay, let's put a 1 in on the left side. 4 times 1 plus 10 equals, put a 1 in on the right side, 2 times 1 times 1 plus 6. So that's 4 plus 10 here. That's going to be 14. Over here I get 2 times 7, and that's going to be 14. So great, it works. Now I'm going to assume it works for n equals k. So I take my expanded notation and I replace my n's with k's. All right, so that's 14 plus 18 plus dot, 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 plus 4k plus 10 equals 2k times k plus 6. Next, we prove it works for n equals k plus 1. So again, what's critical is that you understand you need to take this part of the series, include it in this next step, and then go one term more. So I have 14 plus 18 plus dot, 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 plus 4k plus 10, plus the next term is this expression with a k plus 1 in place of the k. So it's 4 times k plus 1 plus 10. 4 times k plus 1 plus 10 equals. Now over on the right side, I need to replace that with a k plus 1, and I need to replace that with a k plus 1. And still include these other numbers. So use your parentheses. 2 times k plus 1 times, parentheses, k plus 1 plus 6. That's what I get when I replace both of these with a k plus 1. Now, since these two pieces are equal, and this is equal to 2k times k plus 6, I replace all that stuff. So you take that expression, and you replace all of this highlighted stuff here. 2k times k plus 6. Now you write the rest of it down. Plus, I'll distribute here, 4k plus 4 plus 10 equals, now this is going to be a little bit messy. It's not as easy as it looks. I'll do a couple things. Number one, I'll distribute here. So I've got a binomial, that'll be 2k plus 2. And then in the other one, I'll combine the 1 and the 6, that's k plus 7. So at this point, I just need to get all of this stuff on the left side equal to all of the stuff on the right side. It's up to you how you do that. I'm going to work with both sides. So I'll multiply these two out, I'll use FOIL, and then I'll distribute here, combine all my like terms, and end up with two trinomials that hopefully are equal. It doesn't matter what order you do this. I'll work with the right side first. 2k times k is 2k squared. 2k times 7 is 14k. 2 times k is 2k, so 14k and 2k, that's going to give me 16k. 2 times 7 is 14. Now over on the left side, let's distribute. That's 2k squared plus 12k plus 4k plus 14. And lastly, combine like terms, 2k squared plus 16k plus 14 equals, and that's what you have over on that side. So a couple more examples with mathematical induction proofs. Hopefully at this point you kind of understand this concept. Please don't hesitate to reach out if you have any questions whatsoever. We'll have more practice on the review and the work sessions and also on the homework. Thanks for watching, and see you guys in class soon.